Hurricanes are a natural disaster like no other. In fact, they are one of the most violent storms on Earth. The official scientific term for a hurricane is a tropical cyclone. Let's take a look at what fuels these monumental storms, how they form, and of course, the increasing likelihood of bigger and badder hurricanes in the future. What fuels a hurricane? Warm, moist air, oceans with warm surface temperatures, and a nice strong source of wind. The ocean needs to be at least 80 degrees Fahrenheit, that's 27 degrees Celsius, for the topmost 50 meters. Due to these temperature requirements, hurricanes tend to form near the equator. The strong, warm winds blow across the water, causing evaporation to create big, fluffy cumulonimbus clouds. Innocuous as this may seem, this is the very, very beginning of a hurricane. Our fluffy clouds turn into a tropical disturbance. This is basically just a bunch of cumulonimbus storm clouds all slowly swirling together. Here's how it works. As the water vapor evaporates, it rises and releases heat into the atmosphere at higher elevations. A wind that rotates in a circular fashion slowly drops downwards at the center of the building storm, where the air is heated and rises up again. If the winds in a tropical disturbance reach speeds somewhere between 25 and 38 miles per hour, we call it a tropical depression. Air at the top of the cloud system starts cooling, which creates instabilities. Remember that air vapor in the upper parts of the clouds is releasing heat. This increases the air pressure, and air rushes away from the high pressure area, causing the air pressure at the surface of the ocean to drop. This dropping air pressure in turn causes an increase in storms. Once the winds kick up to at least 39 miles per hour, a defined eye of the storm can be observed and we see a clear Coriolis effect. This is called a tropical storm. What is the Coriolis effect, you ask? It's the phenomenon in which the storm swirls clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Once the wind speeds surpass 73 miles an hour and the clouds reach 50,000 feet high and 125 miles across, we call it a tropical cyclone, or a hurricane. The really low pressures near the surface of the ocean cause the ocean water to swell upwards there, which creates storm surges once the storm impacts with land. Once the wind speeds surpass 95 miles an hour, the hurricane progresses from a Category 1 storm to a Category 2 storm. If the wind speeds pass 110 miles an hour, it is rated as a Category 3 storm. From 130 to 156 miles per hour, the storm is rated as a Category 4. Anything with even higher wind speeds is a Category 5 storm. Once a hurricane reaches land, referred to as landfall, the winds propel debris through the air at high speeds and destroy homes and trees. The rain hurricanes bring with them causes flooding, which is often responsible for just as much damage as the high winds. Centuries of research into hurricanes has informed us that when the ocean surface temperatures are warmer, hurricanes will be stronger and last longer. Data shows us that the surface temperature of the ocean is increasing, but many scientists felt they could not blame this on climate change alone, as it could be caused by the Atlantic Multidecadal Oscillation, or AMO, a natural variation in temperature unrelated to human actions. However, Professor Carrie A. Emanuel and Associate Professor Michael E. Mann used statistical analysis to determine how much of the warming effect is due to natural variation and how much is due to human-induced climate change. They found that surface temperatures were mostly being controlled by human-induced climate change rather than natural variation. So, as the world warms, we are likely to see more and more of these severe storms.